Video is to cover the topic of genetic recombination and gene mapping. So using recombination frequencies to create a map of a chromosome. So we're going to split this video up. It's a pretty complex topic. So we're going to go ahead and split this video up into three parts. So I'll go ahead and direct you to the other videos when we're done here. So this is my information. This is my email address. If you have any questions or this video, leaves you a little bit confused, feel free to reach out to me, please. I check my email regularly, and I'll get back to you with a response, and I can work with you one-on-one, anything like that. Okay, so the goals of recombinant gene mapping. The primary goal is to determine the order of multiple genes or loci on a chromosome. And another goal is to estimate the relative position or distance between multiple genes on the same chromosome. And just note here that I say relative because you can't actually say like this gene is 3 micrometers away from this other gene, but you can figure out based on that recombination frequency, you can estimate relatively how far apart they are, if that makes sense. Okay, so how does it work? The underlying principle is based off of crossover, and we all know crossover occurs during meiosis and kind of is defined loosely as the exchanging of genetic information. So here you can see we have one parental chromosome and another parental chromosome. Crossover occurs at a chiasma here, and it's going to result in recombinant daughter chromosomes. So this would be the genetic material of the progeny or offspring generation. So you've probably seen crossover before, so I'm not going to spend too much time on it. But I'm going to go ahead here and show you this example. This is just so you can kind of visualize, because this will come in handy later when we go over an example problem. So we have parent 1, parent 2. We're trying to figure out what the offspring chromosomes would look like if crossover happened right here. So if crossover happens here, you're going to look at this chromosome. We'll start here. Crossover happens here. So the reshuffled or recombinant offspring chromosome would look like this. So start and come down the gene. So A, B, B, C, and then crossover happens. So it's going to come over here, and wild type denoted by the plus. So we can assume that if crossover were to happen here, it would result in the chromosomes AB, BC, plus, and then the same thing for over here if we were to start here, plus, plus, CD. So that's what we can assume would happen. If crossover happens here, this would swap over here, and this would swap over here, and then you exchange that genetic information. And then sure enough, that's what we're going to go ahead and see here. AB, BC plus, or wild type, and wild type, CD. So that's just kind of an example to help you visualize what's going to happen when crossover occurs. This part of the chromosome is going to switch with this part of the chromosome. So you can just kind of, this will make a lot more sense when we get to an example problem in a following video. So another underlying principle of genetic recombination mapping or gene mapping is basically you just have to ask yourself what's more likely. So the idea is that there's genes that are linked, and this is due to the likelihood of crossover occurring between them being relatively small. So what's more likely? Crossover happening between A and C, or crossover happening between B and C? Well, it should be somewhat intuitive that there's a lot more space for crossover to happen between A and C than there is for crossover to happen between B and C. So if you were to have a genetic cross 100 times, it's a lot more like look at how much more room there is. There's a lot more chance, or a much higher likelihood that crossover will happen anywhere in here than it will in this one little area. So therefore, you can say that genes B and C are linked because it's very likely that they'll be inherited together, because it's unlikely that crossover will happen there. That doesn't mean it can't happen, but it's a lot more unlikely that crossover will happen there. So this is kind of how we're going to go ahead and make maps. We're going to figure out, we're going to do a test cross, and we're going to look at all the results, and we're going to say, wow, these genes look like they're inherited a lot together. They must be close together on the chromosome. So that's kind of how this is going to work. Okay, so that's going to go ahead and wrap up video 1. The other video, part 2, should be available. So just go ahead and click over to part 2. But thank you very much for watching. Here's contact information for the ASC, Academic Success Center. And thank you very much.